ATWOOD'S machine. It consists of a pulley with masses on either side of the string. As you see here, this is an example for ATWOOD'S machine. You find a light pulley and a string which is inextensible, and you have masses moving up and down. If this mass is more than mass m2, then mass m will move down and mass m will just move up. So here you find tension will be same on the string completely. Only that these masses will just move up and down. And don't forget that this pulley should be light and it should be having no friction. I mean that there should be no friction between the pulley and the string. So if you see here, we have seen mass m1 is moving down. So in this case, mass m1 moves down just because it is having more mass compared to mass m2. And here it has a force acting called as m1g, and it has a force upwards called as m2a. So now here we have the FBD as shown. We can draw these are the FBDs. Now we can get the equation with the help of this FBD as shown here. Here we get fine. Here we have m1g minus t is equal to m1a. Net force is acting downwards. Therefore, m1g is more than tension. So we can write as follows: m1g minus t is equal to m1a. Now let us see here now. Here you write as follows: T minus m2g is equal to m2a. Here what we see is that tension is more than the force acting downwards, so we get the equation as shown. Now if you solve these equations, we can find the value of acceleration as well as tension. So as you see here, if you solve those two equations, we get acceleration A is equal to m1 minus m2g by m1 plus m2. Similarly, you get tension as 2m1 m2g by m1 plus m2. This is the tension we get by solving this. And we can even find the value of thrust. Thrust is equal to, here you find double tension acting on the pulley. Therefore, thrust will become same as 2t. That is equal to 2 of, the value of t is given here, which we got, 2m1 m2g by m1 plus m2. Solving which you get it as 4m1 m2g by m1 plus m2. This is the value of the thrust acting on the pulley. 4m1 m2g by m1 plus m2. So we got here A as m1 minus m2 of g by the total mass. Same way, tension as 2m1 m2g by the total mass. Now thrust is same as double the tension, so we get it as 4m1 m2g by the mass completely. Now see here, if the pulley is moving, for example, if the pulley is getting some kind of acceleration, it's moving up or down, then the equation changes. What happens when the pulley moves upwards? We shall see here now. You can have a look here. If the pulley accelerates upwards, then the formula changes. We have change in the formula. In this case, acceleration of the pulley becomes A is equal to m1 minus m2 by m1 plus m2 of G plus A. Similarly, tension becomes T is equal to 2m1 m2 by m1 plus m2 of G plus A. Just you are adding plus A as it's moving upwards. In the same way, thrust is equal to the same formula with G plus A. Thrust is equal to, we get here 4m1 m2 by m1 plus m2 of G plus A. These are the formulae when the pulley is moving upwards with some acceleration. Similarly, if the pulley is moving downwards, we shall see what happens then. Now, in this case, acceleration is equal to m1 minus m2 by m1 plus m2 of G minus A. In this we get here G minus A. Similarly, the tension becomes T is equal to m1 minus 2m1 m2 by m1 plus m2 of G minus A. Just replacing G with G minus A, and the thrust acting, the thrust will be same as thrust is equal to, which is 4m1 m2 by m1 plus m2 of G minus A. These are the different terms in the pulley when it's moving upwards or downwards. So let us see next. Suppose you have the blocks of masses as shown here. Yes, you can see here. You can find here there are two masses and you find a string between them. In this case, we shall see what is the acceleration. Okay. Now here, in this case, acceleration A is equal to F by m1 plus m2. In the same way here, tension is equal to T is equal to m2F by m1 plus m2. So the value of acceleration and tension will be as shown over here. So next one. If you have a picture as shown here, now see there are three masses rather. In the first case you are seeing two masses, but now there are three masses as shown here, and you find tension at two different places. First here we should find the value of acceleration here. A is equal to, here we get total force fine. Here A is equal to we get F by the total mass, that is m1 plus m2 plus m3. In the same way, tension T1, we get tension T1 is equal to, here we get m1 plus m2 of F by m1 plus m2 plus m3. Similarly, tension T2 is equal to, here it becomes m3F by m1 plus m2 plus m3. These are the value of tension T1, T2 and the acceleration, right? Okay. Fine. Next one here. If you have a pulley as shown here, then what would be the value of tension and we shall see here. First of all, here we will draw the FBD. In this case, here you can draw as shown here. Okay. Here we have T is equal to, this tension is equal to the mass M1 into A. M1 into A. In the same way, if you draw here net force, if you write the net force here, you get as shown M2G minus T is equal to M2A. From these values, we can find the value of A very easily. So here you can get here, which implies T is equal to M2G minus M1A. So here M2G minus M1A will give the value of tension also. This is one more way.